Hi, and welcome to Algebra 1. This is Unit 4, and these are the notes over systems of equations and inequalities. The first section, what we're going to talk about today, is solving systems of linear equations by the graphing method. So you will want to use your grapher using either Desmos or a graphing calculator or something like that. So we want to use technology to find or approximate the solution of a system of linear equations graphically. We want to analyze a system of linear equations to determine if it has one solution, no solution, or infinitely many solutions. Okay, so we have certain types of solutions. Okay, you can either have one solution, no solution, or infinitely many solutions. And when I talk about a solution to a system of linear equations, the question that I ask myself is, where do the lines intersect? Okay, I asked that question, where do the lines intersect? So the solution is a point on the graph, and that's an x and y value on the graph where the lines intersect. So where the lines intersect. Okay? And so what we look at, if we have one solution, we have one point, okay, where they intersect. So one point of intersection. All right, and that's our solution, okay? If we have, and that's when you have lines that have different slopes, okay? If you have the same slope, but different y-intercepts, meaning you have parallel lines, okay, parallel lines, then there's no solution because there's no intersection. Okay? Then, all right, the next thing we want to look at is if you have the same line. Okay, if you have one line that's on top of the other, then you have infinitely many solutions because you have all of these different intersection points that go on forever and ever and ever and ever and ever and ever in the same direction, in both directions. And they'll just have an infinite number of intersection points. So that's what we're looking for, okay? So the first thing we want to do is just think about, how do we solve a system of linear equations by graphing, okay? And the first thing I want to do is kind of just look at both of these and graph them on this equation here. Okay, I have a slope of negative 1/4, and I have a y-intercept of 1, okay? So my y-intercept of 1, this is my starting point, okay, this value for b. So go to my y-intercept, find 1, and then I'm going to plot my next points by doing the slope of negative 1/4. So I'm going to go down 1 and then over 4. And then I'm also going to go up 1 and to the left 4 units and plot those points. All right, so I'm going to connect those like so and like so. Okay, so you get the idea. Then on the next one, what I want to do is I want to graph x minus y equals 4. Now that one's a little bit trickier. What I want to do is solve this for y. So I'm going to subtract an x. So I get negative y is equal to negative x plus 4. Divide by negative 1, divide by negative 1, and divide by negative 1. And so I end up getting y is equal to x minus 4, okay? Now, in this equation, my slope, m, is equal to 1, and my y-intercept, b, is equal to negative 4. So I come over to my y-intercept, and I'm going to use red for this. But negative 4 is my y-intercept, okay? Plot that point. And then I have a slope of 1, so I'm going to go up 1 over 1, up 1 over 1, keep plotting the points, and oh my gosh, that's where it intersects. Okay, that's pretty awesome. So in this point right here is my happy place, okay? That's the point of intersection. And by happy place, I'm going to put a little smiley face here and show my happy place, okay? And so my happy place is the point where we're trying to find. Okay, this point right here is the solution to our system, okay? And so that's going to be the point 4, 0, all right? Now, if I were to really solve this, I know that x is equal to 4 and y is equal to 0, okay? But I want to, make sure we write it in a number of ways, either as an ordered pair or just simply say x equals 4 and y equals 0. Now what I'm going to do is I'm going to graph both of these equations in Desmos, because you could do that too. Okay, some of these you'll want to do it in Desmos. Others you can do it, graphically, just by the way I did it here. Okay, so let me do that real quick, graph them in Desmos, and then we'll show you we get the same thing. Okay, so I went ahead and graphed it in Desmos, and I graphed this equation in slope-intercept form, and then I graphed this equation that's in standard form. And that's what I like about Desmos, is that you can graph equations, so you can graph equations in standard form, all right? And that is what's really nice about it. And guys, I would really encourage you to use Desmos as a tool to help you understand what's going on, okay? And we do, in fact, get the point of 4, 0, which is what we got graphically here. That's where our happy place is, okay? So now what I want to do, let's do the same thing over here. And I'm just going to go ahead and graph. Let me turn this top equation into slope-intercept form and graph it from there. And so I'm going to go ahead. Let me rewrite it. X plus 3y is equal to 12. Let me subtract an x from both sides. So then we get 3y is equal to negative x plus 12, and then divide by 3 and 3 and 3. So we get y is equal to negative 1/3 x, and then plus 4. All right. Now, what I notice about this equation and the one we just had was that these graphs have the same slope. Okay, so they have the same slope, so the lines are parallel. All right, and so we don't really need to go any further from this, but I do want to show you that that's what we get. So here, I know that my slope is equal to negative 1/3. My y-intercept is 4. So I'm going to plot the point 4 up here, and then with a slope of negative 1/3, I'm going to go down 1 over 3, down 1 over 3, okay, up 1 to the left 3, and then up 1 to the left 3. Okay, so now, I'm going to connect all these points with a line as best as I can, all right, and then the other one, we had a slope of negative 1/3, and then we had a y-intercept of negative 1. So I'm going to do the same thing over here, negative 1, plot negative 1, and then my slope is down 1 to the right 3, down 1 to the right 3, and then up 1 to the left 3, and so on. So we end up getting the same thing here. And so because these lines are parallel, so lines are parallel, there's no solution. All right, there's no intersection point. All right, no solution. All right, and so that's all we've got is just that scenario. Now let me graph both of them. I'm going to graph it in standard form and in slope-intercept form so we can see, and then we can just make sure that we did it correctly. Okay, so what we can see from this is that both of these lines are parallel to each other, But the cool thing is that I graph this in standard form. Again, for me to I can graph it in standard form algebraically, but, I prefer to usually just do, slope-intercept form. That usually just works, just as good. So I just wanted to show you that both of these are, they're there. All right. Okay, now let's try this one. Now I'm going to go ahead and graph this first one, and this is, in slope-intercept form, so my slope is equal to 3/2, and my y-intercept, b, is equal to negative 3. So my y-intercept is negative 3, and my slope is positive 3 over 2. So I'm going to go up 3 and over 2, up 3 over 2, up 3 over 2. And then down 3 to the left 2 and plot those points. So I'm going to go ahead and connect those with a line, And then I want to graph this one, And I'm going to go ahead and solve this for y, and I'm going to go ahead and subtract 3x minus 3x. I get negative 2y is equal to negative 3x plus 6. I'm going to divide everything by negative 2. Oh, crap. Oh, man. What do you mean? Okay, y equals 3, positive 3 halves x minus 3. Now, wait a minute. This is the same thing. Okay? So we have the same line. So with the same line, I have an infinite number of solutions. Okay? Because I know that my slope here is 3 halves and my y-intercept is negative 3. Okay? And so when I graph that here, okay, I have up 3 over 2, up 3 over 2, down 3 to the left 2. I get the same thing, okay? And so, just to make sure that we do have the same graph, I'm going to graph both of these on Desmos and just verify real quick. Okay, so after graphing these, what I notice is that I have the same line, okay? I should have a red and a blue line, but because the blue line is the second one down, it's the one that's going to show up. So it is the same line. And so we have an infinite number of solutions. We have an infinite number of points at which those two lines will intersect. Okay. Okay, this last problem on the next page, it says verify the solution of the given system of equations is 1.1 and negative 2.8. So what I'm going to do is I'm going to graph these in Desmos. So graph in Desmos and verify that that is the intersection point. So let me graph those and I'll put that picture up here in a second. Okay, so what I've done, guys, is I've graphed both of these equations, and I have found the intersection point, and it works out that that's the intersection point that we get. So, that's the thing, is you need to be able to graph these in whatever form they're given in, and just type them in as you see it, and Desmos will graph those lines, okay? Wouldn't hurt to do this in, doing it the other way around, and then we'll look at some ways to do this algebraically in the next section. So I hope you enjoyed it, and I had a lot of fun making this video. And we'll talk to you later. See ya. Bye!